Welcome back to session 13 of GED Science Mastery. This is a big milestone. We are stepping into physical science, which is about 40% of the test, and it all starts here with the atom. Everything around you, the air, the water, your body, this screen, is built from atoms. If you understand the three particles inside an atom and how the periodic table is organized, a whole family of chemistry questions suddenly opens up. Let's build matter from the ground up. Picture an atom like a tiny solar system. In the center is the nucleus, a dense core packed with two kinds of particles: protons, which are positive, and neutrons, which are neutral. Whizzing around the nucleus, like planets around a sun, are the electrons, which are negative. Almost all of the atom's mass is in that tiny central nucleus because protons and neutrons are heavy, while electrons are incredibly light. So, heavy nucleus in the middle, light electrons orbiting around it. Let's nail the three particles cold, because everything depends on them. A proton has a positive charge and sits in the nucleus. A neutron has no charge. It is neutral and also sits in the nucleus. An electron has a negative charge and orbits outside the nucleus. Two quick facts that the GED tests. Electrons are negative, not positive, and the mass lives in the nucleus with the protons and neutrons. Positive proton, neutral neutron, negative electron. Say it until it sticks. Now, two numbers that unlock the periodic table. The atomic number is simply the number of protons, and it is the atom's identity, its ID number. Every carbon atom has exactly 6 protons. That is what makes it carbon. Change the proton count, and you change the element entirely. The mass number is the number of protons plus the number of neutrons. Electrons are too light to count. And in a neutral atom, the protons and electrons are equal, so their charges cancel out. Two words the GED loves to test together. An isotope is the same element with a different number of neutrons. Same protons, different neutrons. So isotopes are still the same element, just with different mass numbers. An ion is different. It is an atom that has gained or lost electrons, giving it a charge. Gain electrons, and the atom becomes negative. Lose electrons, and it becomes positive. So isotopes change the neutrons, but ions change the electrons. Keep those two straight, and you will not be fooled. Let's read a real GED-style table. A class recorded the particles in 4 atoms. Atom W has 6 protons, 6 neutrons, and 6 electrons. Atom X has 8 protons, 8 neutrons, but 10 electrons. Atom Y has 6 protons, 8 neutrons, and 6 electrons. And atom Z has 11 protons, 12 neutrons, and 11 electrons. Read carefully, because in the next step, we will use the proton and electron counts to spot an isotope pair and an ion. Notice already that W and Y both have 6 protons, and that X has more electrons than protons. Let's solve it. Which two atoms are isotopes of the same element, and which atom is an ion? Read. The atomic number is the proton count. W has 6, X has 8, Y has 6, Z has 11. Choose. W and Y are isotopes because both have 6 protons, which makes both of them carbon, but they have different neutron counts, 6 versus 8. And X is an ion because it has 8 protons but 10 electrons. Those 2 extra electrons give it a 2- charge. Check. W, Y, and Z each have equal protons and electrons, so they are neutral. Only X's electron count differs, making it the ion. Finally, the periodic table itself. It is simply an organized chart of all the elements listed in order of their atomic number, that is, by their number of protons. The columns are called groups, and the rows are called periods. Here is the useful part. Elements in the same group behave in similar ways because they have similar numbers of outer electrons, and it is those outer electrons that drive chemical behavior. So the table is not random. Its layout actually predicts how elements will act. Let's lock in the traps. 1. Thinking neutrons set the element. No, protons set the element. Changing neutrons only makes an isotope. 2. Counting electrons in the mass number. No, mass is protons plus neutrons only. 3. Thinking an ion is a broken atom. No, an ion is just an atom with a charge from gaining or losing electrons. 4. Thinking electrons are positive. No, electrons are negative. Protons are positive. The recap. Protons give identity. Mass is protons plus neutrons. Isotopes change neutrons. And ions change electrons. Superb work today. You can now name the 3 particles and their charges, use the atomic number, and tell an isotope from an ion. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, and when a question asks about charge, just compare the protons, which are positive, with the electrons, which are negative. To read the full lesson notes and practice more GED science questions, visit the course page at www.bridgetoexam.com. I am proud of you. I will see you in session 14, where we explore matter, states, density, mixtures, and solutions. Keep going. You are doing great.